Now let's move on to lesson 2, minimum tillage and surface composting. In order to maximize the benefit of growing a cover crop for the soil, how the stand is incorporated into the soil after it has done its job is crucial. Ideally, the cover crop should be mulched, creating more surface area for decomposition to occur, treated with a ferment, and then shallowly incorporated into the soil, for example through tillage. Before diving into this topic of tillage options for regenerative agriculture, I would like to give you an overview of different wordings and techniques. Minimum tillage is a low-impact tillage method and soil conservation system where soil is not turned over, in contrast to when working with plows. Minimal tillage attempts to leave the soil structure as much as possible intact and manipulate the soil as little as necessary for ensuring successful crop production. No-till farming or direct drilling is a tillage technique for growing crops or pasture without any disturbance of soil through tillage. No-till practices allow the soil structure to stay fully intact and protect the soil by leaving maximal crop residue on the soil surface. Strip till combines the soil drying and warming benefits of conventional tillage with the soil protection advantages of no-till. Strip till means working and disturbing only the portion or strip of the soil where the plant row is being planted. As written in the paper, the effect of minimum tillage and animal manure on maize yields and soil organic carbon in sub-Saharan Africa, a meta-analysis, quote, different tillage methods have different outcomes on crop production and soil health. Minimum or reduced tillage involves minimal soil disturbance, which results in several advantages. Minimum tillage augments soil's physiochemical and biological properties through reduced soil erosion, thus allowing soil organic matter build up. It also decreases compaction, reduces erosion and runoff, and conserves soil microbial activity. However, it is difficult to control weeds when minimum tillage is used, thus heavy reliance on herbicides. Also, crops grown under minimum tillage are more adaptive to climate variations and have higher yields than in conventional tillage. Minimum tillage allows for partial subsoiling for soil aeration to speed up the process of roots taking over once compacted deeper soil horizons. In this example, we will look into the practical application of surface composting as a minimum tillage method used at Schloss Tempelhof Farm, as well as many other regenerative farms. Our goal here is to incorporate the biomass of the cover crop into our soil so that contact between plant matter and soil occurs. This prevents the nutrients from the cover crop escaping into our atmosphere in gas form. In order to retain the maximum amount of nutrients and thus build humus, the plant matter should directly be mixed with biologically active topsoil. The combination of organic fragments or plant residue with inorganic particles such as clay minerals create what are called clay-humus complexes. These complexes stabilize the soil against erosion, create favorable conditions for air and water balance in the pore volume of the soil, and thus help increase soil fertility. Often the biomass stems from a cover crop which is then shallowly tilled using an adapted rotary tiller. The rotary tiller should have knives set as an 90-degree angle to precisely undercut the stand. We use support wheels to make sure that we are not cultivating deeper than necessary. Similarly to what we learned in Lecture 3, vegetable systems, if the cover crop grew more biomass than the equipment can handle, preparation with a flail mower prior to the tilling is an option. If a flail mower is being used, this should always be done right before mixing the plant residues with the topsoil to avoid nutrient losses. With a working depth of about 5 to 8 centimeters, we ensure that the root biomass under the working depth of our tiller is still intact and offers pores for air and water penetration, as well as pathways for new root growth. Mixing effects of tillage tools like the rotary tiller get cover crop biomass in contact with the topsoil and, depending on the soil type, also the clay particles. An important step to form clay-humus complexes in this case. In some areas of regenerative agriculture, the use of compost teas or ferment products like, for example, lactic acid bacteria can be an additional tool to manage the surface composting process, especially if large amounts of biomass are being incorporated into topsoil. Ferment products are used to steer the composting process microbially in the right direction of nutrient incorporation into the soil structure, rather than losing them into the air via washout into groundwater. Their function can be compared to silage additives in fodder production, for example. The field of compost teas and ferment products is still quite young, and though many farmers are convinced of the effect, very little research has been done on the subject. Regenerative farmers often work with adapted spraying equipment that is attached to the rotary tiller or the flail mower. These are steps of this procedure where the biggest surface area can be treated with simple equipment. After the incorporation or the incorporated material has composted for about 2 to 4 weeks, depending on temperatures and moisture, the soil is ready for the following crop. Summarizing, surface composting is a soil structure-friendly way to efficiently make use and give the soil back maximal nutrients and biomass for crop residue or cover crops. The combination of organic fragments with inorganic particles, such as clay minerals, create what are called clay-humus complexes. These complexes stabilize the soil against erosion, create favorable conditions for the air and water balance in the pore volume of the soil, and thus help increase soil fertility. Thank you for attending this lecture.